Hi guys, I will actually teach you today about a question involving buffer solution calculation. And unlike simple calculations, okay, by using the formulas, okay, to normally calculate the buffer solution, we do have some difficult questions that requires you to do further analysis and further evaluation and then to reach the answer. So I'm actually going to try to solve this question for you. So do remember, you need to have some knowledge about how to use the formulas for buffer solution and so on. Okay, so we will actually start now. So you can see here, okay, when chlorine dissolve in water, the following reaction occurs. Okay, so they have written in this way. And then when the solutions of chlorine are used for water purification, the pH of the chlorine is kept near to pH 7 by the addition of a base. So here, okay, they have given you some information in every 1 dm cube. So all these are happening in 1 dm cube. For every 1000 cm cube of a solution, it contains 0.17 moles of HClO and 0.17 moles of HCl. So to represent this, okay, I will rewrite this equation as Cl2 plus H2O to give me HClO plus, just rather than separating H plus and Cl, I will just write down HCl. So I will actually put down over here the number of moles. The number of moles HClO is going to be 0.17, and this is going to be 0.17 also. Now, a buffer solution now is going to be prepared. Okay, so we are going to prepare a buffer solution by adding sodium hydroxide to this solution. The sodium hydroxide initially reacts with HCl. Okay, they mentioned that when you add sodium hydroxide, it reacts with HCl. Okay, let's actually look at it in a much more easier way. Okay, what is happening now is when you have Cl2 with water, you are going to have HClO and HCl, and it's not a reversible process. It means that when you add, all the Cl2 has completely reacted with water, and now you have HClO and HCl. I think it's easier to look at it in that way. And then you are adding 0.2 moles of sodium hydroxide into this solution. And they have mentioned that sodium hydroxide, they will react initially with HCl. Let's actually write the equation for that first. So NaOH reacts with HCl. They are going to give you NaCl plus H2O. So it's just a simple neutralization reaction. And do remember, NaOH, I have 0.2 moles. So I'll write down all the number of moles that I have. Okay, 0.2 moles. HCl, I have 0.17 moles. So if you look at these numbers over here, you will notice that there is one of the reactant that is going to be in excess. And I hope you can see and identify which one is in excess over here. So the one that is going to be, if you look at the stoichiometric equation, one mole react with one mole to give you one mole to give you one mole. Okay, and I see that this is going to be in excess. Okay, sodium hydroxide is going to be in excess. So to be exact, what will happen? How much number of moles of sodium hydroxide will react? They will react 0.17, will react with 0.17 to give you 0.17 to give you 0.17. So there is going to be excess of sodium hydroxide or balance, okay, of sodium hydroxide as much as 0.03 moles. Okay, how do I get 0.03 moles? Basically 0.2 minus 0.17. Okay, so that's extra. Okay, the extra sodium hydroxide. So it means that in this case, when I react with the HCl, I reacted completely with the ACl. Let's actually start to eliminate so that we can actually identify or narrow down the scope over here. ACl is completely reacted. No more ACl anymore. Okay, no more ACl anymore. And of course, you have sodium chloride, you have H2O, you have sodium hydroxide. And we know that this is going to be HClO. I think it's actually, they have mentioned over here, it's a weak acid. So now you have 0.17 moles of HClO, which is a weak acid. And acid should react with base. And I have 4 solutions here: weak acid, sodium hydroxide, sodium chloride, and water. So do take note, when they say react initially with ACl, sodium hydroxide, react initially, it means the sodium hydroxide can also react with something else. Okay, in this case, sodium hydroxide will react with the HClO now. So I will write down the equation for HClO plus NaOH. So this is basically a neutralization reaction. Okay, it's a weak acid with a base. Okay, so you will have water being produced, and then you have, okay, NaClO plus water. And when you look at the number of moles, okay, do remember earlier the excess, okay, was 0.03 moles. And do remember HClO, we had 0.17 moles of HClO, 0.17 moles of HClO. And then let's actually identify which one in excess and so on. Every 1 mole will react with 1 mole to give you 1 mole and 1 mole. And you can see there is one solution here that is going to be in excess. Okay, you can see very clearly this is going to be in excess. So we want 0.03 of this react with 0.03 to give you 0.03 and 0.03 here. Okay, so what is going to happen? There is going to be still excess or balance for HClO. How do I get the balance? 0.17 minus 0.03. That's going to be 0.14 moles of HClO. So now to make our life easier, let's actually eliminate. Okay, let's actually narrow down. Okay, what are the things don't have anymore? Okay, we have completely used the 0.03. Used up. Okay, there's no more NaOH anymore. No more. Done. So you are going to have NaCl, H2O, HClO, NaClO, H2O. And now the combination of two things will give you the buffer. So let's actually figure out which one will give you the buffer solution. Yeah, which one is going to be buffer. So in order to have buffer, you need a weak acid. Okay, they already mentioned just now is a weak acid buffer. So the weak acid that I can see from here is going to be HClO. This is going to be the weak acid. And the weak acid, okay, should also have the salt of the weak acid, which is going to be the conjugate base. Okay, the conjugate base that is going to be responsible, okay, for the buffer. Yeah, so you can see the conjugate base will be the ClO minus. Is going to be that is coming from here. Okay, that is coming over here. So in this case, what are the things that we will not use? Okay, if I circle the things that I will not use, I will not use water. Okay, I will not use water. I'm not bothered about sodium chloride. Okay, the only thing I'm bothered now is, okay, I'm bothered about this, to be exact, the balance. I'm bothered about this. So let's actually look at the buffer. Okay, when I have this buffer, how do I actually write down the buffer equation? Yeah, the equations for this buffer. HClO, okay, when they are weak acid, so H plus ClO minus. And then you have NaClO. They are going to give you Na plus and ClO minus. Okay, so do remember this is the conjugate. base. Okay, conjugate base. So this is going to be a buffer solution, okay, when you have this buffer solution. So let's actually put it down in terms of number of moles, yeah. So the number of moles of NaClO is going to be 0.03. This is 0.03. So this is going to be 1 mole, give you 1 mole and 1 mole. So 0.03, 0.03. And then if you look at the number of moles of HClO, the balance, okay, is going to be the leftover, okay, after reacting with the NaOH is 0.14. So this is going to be 0.14. Okay, that's the initial concentration of HClO. We need to find the concentration of H plus and to be able to calculate the pH of the buffer. So this one, if you want to actually write down the equation yet, so you need to know this, okay? Ka, okay, for a weak acid, Ka is going to be acid dissociation constant is H plus times the ClO minus divided by the concentration of HClO, okay? So what is going to happen is I need to find the pH. So concentration of H plus is going to be Ka at times with the concentration of HClO divided by concentration of ClO minus. So Ka value, okay, is given. Ka value is 2.9 times 10 negative 8. So I just need to put 2.9 times 10 negative 8 times, okay, HClO. HClO is going to be, you just take the initial part over here. So these are assumptions, yeah. So please actually remember the assumptions when we use this formula. The dissociation is too small until we assume there is no dissociation. So we take the initial concentration of the weak acid. So this one is all part of the formula. So please actually learn how to apply this formula. This is number of moles. Do remember just now everything is in 1 dm cube, okay, earlier. So you're just going to be divided by 1. Okay, that's concentration. This divided by ClO minus, okay, ClO minus. This one, okay, all these things, this is too little, okay. This is the amount is not coming directly from the HClO. It is going to be counted from the salt, okay. So this is important, okay. The conjugate base, the concentration of the conjugate base over here is going to be 0.03 divided by 1, yeah, 1 dm cube also. So you are going to use 0.03 divided by 1, and we are going to just calculate this, okay. When you calculate, okay, let me quickly calculate this. 2.9 negative 8 times 0.14 and then divided by 0.03. You will get 1.3533 times 10 negative 7. This is again concentration of H plus. You need to calculate, okay, you need to calculate the pH, okay, the pH. So the pH is going to be the formula, pH equals to negative log concentration of H plus. So it's negative log 1.3533 times 10 negative 7. If I use the values in my calculator, just negative log answer, okay, you will get the answer as 6.868595 or something. But it is important to simplify that, okay, simplify that to become 6.87, 3 significant figures. So this is going to be how you try to solve this question. Okay, this question, you need to actually analyze this properly, and then you need to come up with the buffer solution and then try to apply the formula and get the answer. So the answer for this is going to be 6.87. So if you like this video, okay, and you are not my student, if you still want to follow whatever things that I'm teaching you, please consider liking the video and subscribe. Okay, that's all guys. Okay, see you. Bye.